Newton's laws of gravitation. The mechanics that we are studying is called Newtonian mechanics. The modern mechanics is called relativistic or latest mechanics. In classical mechanics, it's all based on Newton's laws. And Newton's two prominent laws are one for the straight line motion, that is Newton's second law of motion, and the other is law of gravitation. It deals with the forces between two objects having mass. It is applicable for any of the objects having masses between the entire universe. And for these laws or for this force, contact is not essential. The object might be at greater distance also. Like two masses you consider m₁, m₂, distance between them is r. Law is depicted in two parts. One says proportional to m₁, m₂, other says proportional to 1 upon r square. On combining the two, ultimately we get this law, and the proportionality constant is capital G. This is called universal gravitational constant. Universal gravitational constant. Its value is very small. It says by itself that gravitational force will also be small. Unless the body is very big in size, like astronomical objects, the gravitational force is not very considerable. And this gravitational force applied by the Earth on some object is known as gravity of Earth. This force, first of all, you should know it is universal constant. It's called universal because it's not affected by any factor like pressure, temperature, place, height, and all that. Then this force has some very specific character, like it does not depend on the object between them. What is the medium between the two objects is not material. Means it will apply the force on the other that will remain unchanged whether third block is introduced here in between or not. Moreover, this force is always applied equally by both on each other. This force is always along the line joining them. The gravitational force, electrical and magnetic force, if you consider, these are comparatively bigger in size. Size means the bulkiness or the strength of these forces would be greater compared to gravitational force. Cavendish helped in calculation of gravitational constant by using torsion balance method, and he got the value of capital G.